Welcome to my presentation. I am Mohammad Jahid Hassan, Assistant Professor, Department of CSC, Dafur International University, Bangladesh. I am going to present my paper titled Burst Header Packet Flood Detections in Optical Bus Switching Network using Deep Learning Model. In presentation outline, I will describe the problems found in OBS network, Optical Bus Switching Network, along with our research objectives. Previous works will be discussed. I will describe the proposed methodology, and then the results will be shown, and finally the conclusion will be drawn. So in optical bus switching network is mostly victimized to the denial of service attack, which referred as the burst header packet flooding attack can prevent reasonable traffics from keeping the necessary resources at transitional core nodes. And the attack scenario is to flood the malicious BHP without acknowledging data burst, which can affect the low bandwidth utilization, degrade network performance, high data loss rate, and ultimately denial of service attack. So the specific objectives of our research which are as follows. We propose a deep learning method based classifiers which can improve the decisions of the classifiers and can automatically detect the edge nodes at an earlier stage. And the proposed model actually is working better rather than the other traditional machine learning model like naive-based support vector machines and k-nearest neighbors. So in related works, in our proposed work, we actually used the deep convolutional neural network and got 99% accuracy to identify the ingress nodes. And I'm going to skip the description of those papers. Anyway, another papers the Rajab actually used the decisions tree algorithms to classify the ingress nodes and got 93% accuracy. Another works they actually used the correlations informations for detecting the ingressing nodes. They used a k-nearest neighbor machine learning algorithm and got 94% accuracy. And radial basis functions, neural network, and support vector machines used another machine learning approaches used in another works. So in our proposed methodology, the concept of deep convolutional neural network used for the estimate of edge nodes of optical bus switching networks. As input, we used a single vector in our network, considering the input and considering the input layer of the DCNN, and convolutional layers followed this. In convolutional layers, every neuron obtains some input and accomplishes dot multiply operations. In convolutional layers in a network are known as a robust pattern indicator of local features. So our two convolutional layers is followed by another dimension of max pooling layers, and low level features can be extracted from the convolutional layers in a network, whereas the max pooling layer is used to extract the high level feature information from information in a network, is to increasingly reduce the spatial size of the representations to reduce the amount of parameters and computations in the network, and also control the overfitting problem. Another two layers of ReLU and dropout is used in our network, and the last fully connected layer is followed by these two layers. And we use a backpropagation algorithm in our methodology for training purpose, and softmax layer used as a loss functions, and that has to be represent the predictions of the probabilities of our classifiers. So we have used 11 performance matrices to classify our works, and I'm actually going to skip the formulas of these matrices, and you see in this in here. And in the result sections, I would like to say that our proposed model DCNN, which will actually true positive rate is 211 and true negative rate is 422, whereas the only one false positive false negative is 1 and false positive rate is also 1. And if you compare to another algorithms like which is closer to DCNN, that is SVM, which will actually true positive and true negative rate is respectively 172 and 412, but they have misclassified the false negative rate is 40 and false positive rate is also 40. So we have tested 635 data for testing purpose, and we have used value, and you see in this figure that is actually the SVM is better in true negative rate, and also you see the true positive rates, and false negative rate, false positive rate is almost actually 0. So so the next, from the next figure you actually see in the previous slides I have talked about the classification performance matrices that I used in our paper. So in the first one, if you see the classification accuracy, so the SVM is better than other algorithms because it got the accuracy level of 99%, whereas the SVM, which is near to 93% accuracy. And if you see the false positive rate, false negative rate, which is almost 0 in our SVM, in our proposed methodology DCNN, and you see the others performance matrices where the SVM is best than others. So from in the figure 3, then you see that the training accuracy versus validation accuracy, where the DCNN the accuracy model, which is started a very sharp accuracy from the very beginning epochs, and reaches the accuracy level of 99% in here. And if you see the figure 4, then the training loss, it can be seen that the model has approximated the same performance regarding the training loss versus validation loss, and the loss level is getting low with the increase of number of epochs. So in conclusion, from our research, we proposed a deep convolutional neural network that will automatically detect the ingress nodes based on their behavior and the amount of reserved resources that are not being utilized. It also can identify by our methodology, and in this methodology we actually work with a limited number of feature data sets, but we got a very good accuracy, and as a result we can say that our proposed methodology is actually outcomes based rather than the traditional machine learning algorithm like SVM, KNN, and naive based models. So these are the references that we are used in our paper, and thank you so much. So do you have any questions?